Well, kids, you have no idea how hot it is here in Mumbai as I'm sitting without an AC and the fan is not helping at all. It is very hot and very humid, but we have to do this, okay? So let's look at some of the data we gathered from going back in time with this time machine into the ice core. This one is from this is data from Mauna Loa here combined with ice core data before 1958. Remember, we were just looking at this, this one is just 1750 or so to 2020. Now you look at this one. This is going back 800,000 years. 8 lakh years back. So the piece we looked at is right here. Immediately tells you that we have crossed the 400 ppm level here. This data is only for, up to 2017. You know now that with 2024 we are somewhere around 425 ppm or so. So we get some older figures, but it doesn't change the story. So you combine the recent data from after industrial revolution with the past data going back to 800,000 years from a long time machine from Antarctica, because Antarctica has been collecting snow and growing glaciers for millions of years. We know that from science and the detective work. So you are looking here at CO2 concentrations in parts per ppm. What is the pattern you see? The first thing you see is that now, as of the 20th or 21st century, we are higher in concentration of CO2 in the atmosphere compared to any time in the past 800,000 years. We are really increasing CO2 at a level that hasn't been seen for a long time. You can't even imagine, if you're a kid, how long ago 800,000 years is, but it's a very long time ago, kids, so just remember that. So what else it is showing? It is showing again this kind of a sawtooth pattern. There are ups and there are downs, and the CO2 concentration is going up and then it is coming down, and there is a change of about 100 ppm between the peak and the valley. And you can also see, if you are keen, you will observe that some rise here. The CO2 is increasing, let's say here about 190 ppm 800,000 years ago, very rapidly to about 260 ppm. Then very slowly, compared to this rise here, it is slowly falling down, jumps up again and increases, and jumps down again and jumps up again, and so on and so forth. This is actually related to something you already learned. We use the description ice albedo feedback. Albedo is the reflection of the sunlight back to space, so it's the loss of energy before it does anything in the Earth system. And ice is, of course, either growing or retreating, and when we say ice, we mean snow cover, glacier cover, and so on and so forth, right? And we already said, when there is an ice age, CO2 in the atmosphere is reduced because it covers the vegetation, it covers land, sea ice covers the oceans, and CO2 gets trapped in the ocean, on land, and so on and so forth. So atmospheric CO2 begins to decrease as ice cover begins to build, right? That's a very simple story. And now you can use your ice albedo feedback. It's as complicated if you're really very young, grade 7 or lower, let's say. This may be a bit difficult to understand, but just listen to it. If you can understand, great. Ask questions and see if you can understand more. But if you're in the 12th grade, maybe you can begin to get a hang of it and follow up with other podcasts and YouTube videos and so on. So what is happening? If you are going from low CO2 to high CO2, that means you are melting away the ice and the glacier. It's getting warmer. right? We know this much. When it is decreasing, that means ice cover is increasing, glaciers are growing, so CO2 is getting buried, and when the glaciers melt, all that CO2 is getting released. What do we know here? We can see that this increase happens relatively rapidly compared to the decrease. Increase happens relatively rapidly compared to the decrease. Rapid increase, slow decrease. Rapid increase, slow decrease. Right? Why is that? This relates directly to what you already know. You just have to put it together and add just a little bit more information. You already know if snow cover and ice cover, glacier cover begins to increase, the albedo begins to increase because snow, ice, glaciers are very reflective. They reflect more and more of the sunlight. So let's say something changed in the orbit and temperatures began to warm, more energy started to come in, or the distribution of the energy from the north to south changed, and the glacier begins to melt. If the glacier begins to retreat or melt, the snow cover begins to melt away, the albedo decreases, which means less of the sun's energy is reflected to space, which means temperatures increase, which means more snow and more glacier will melt. Right? This is a positive feedback. Initial perturbation from the orbital change and the energy received begins to decrease the snow cover, ice cover, glacier cover, which decreases the albedo, which means more energy is staying because less is getting reflected. More warming happens. More warming means more melting, and this can go very, very quickly. Okay, so the melting phase and the increase of CO2 goes very rapidly. Okay, this is the growing phase. Let's say again the orbit changed and the amount of energy coming in decreased, so things began to freeze, snow began to accumulate on land, and sea ice began to grow, and CO2 began to decrease. Two things are happening. You are increasing the albedo because you are beginning to increase snow cover and glacier cover. So albedo increases means more energy is being lost, and more CO2 is being taken out of the atmosphere, which means greenhouse effect is decreased. You are trapping less of the thermal energy, more is going out, so you are losing short wave, and you are keeping you are losing more of the short wave because you are increasing albedo, you are reducing greenhouse gases, so you are allowing more thermal energy to go out, so you are cooling the temperature, which should build more glaciers and more snow cover. But why is it becoming slower than here? This is a bit tricky. As you cool the temperature, what happens to the water vapor? You know that cold atmosphere holds less water, warming atmosphere will hold more and more moisture. If you have less and less moisture as ice cover is building, albedo is increasing, CO2 is decreasing, energy is decreasing, then the snowfall precipitation will decrease because to make snowfall you need more humidity. Dry air has less humidity, so snowfall rates begin to decrease, which means glaciers grow, but they grow slower and slower and slower. So the cooling becomes slower and slower and slower, but it does continue to cool. So the warming part is very fast, but the cooling part is got similar ice albedo feedback, albedo increasing, temperature decreasing. In the warming side you have albedo decreasing, temperature increasing, so the cooling part goes slower. Listen to it again carefully and make sure you understand if you're old enough, and then you connect it to what's happening now. What are we doing now? We are increasing CO2, we are increasing greenhouse gases, we are trapping more thermal energy. Orbits are not changing so much in the last 10,000 years. They have changed a little, but the main thing we are doing is increasing greenhouse gases, trapping more thermal energy, and hence melting glaciers and snowfall, snow cover. Not snowfall, snow cover, because warm means you'll melt the snow. which means you are decreasing the albedo and increasing the CO2 as well. So you're keeping more and more of the solar energy and the thermal energy, so you are beginning to accelerate. So we are in this phase of the ice albedo feedback, which means the melting of the Greenland glacier and the Antarctic glacier and the Himalayan glaciers and these glaciers and so on can begin to accelerate, and there is some evidence that they are already accelerating, which is bad news. In fact, Venezuela, I think, just lost all of its glacier cover, one of the first countries to do that. Arctic is losing its sea ice because of all this warming. We'll see this later again when we go into how warming is happening, right? So this figure is so full of information accumulated from the time machine, the detective work and so on, that you should look at this for a year and make sure you understand it, and understand that we are increasing greenhouse gases at a very rapid rate, and we are out of any range of CO2 that has been seen for almost 1,000,000 years and maybe longer. Okay, so naturally you have ice ages here. Whenever you have low CO2, there was an ice cover over large parts of the earth. Whenever it's melted away and CO2 is high, the glacier cover was removed, completely removed. Of course not, because even now we have glaciers on Greenland and glaciers on Antarctica, so it doesn't completely disappear. But when you have an ice age, most of North America will be covered in glaciers, most of Europe and Siberia and so on will be covered in glaciers, and Indian monsoon will have changed, ITCZ would have changed, temperatures, we will see this animation in the next section, temperatures would have cooled tremendously everywhere on earth and so on and so forth. What an amazing time machine, what amazing detective work, what amazing information, and it shows you how the earth system interacts with CO2. So when we are increasing CO2, we know that it is dangerous because it begins to do so many things. It begins to warm temperatures, increase water vapor and have a positive feedback and accelerate the warming, begin to melt snow cover and glaciers and raise the sea levels, which we'll again listen to later on, and decrease the albedo, trap more energy, accelerate the warming, accelerate the increase of CO2 and so on and so forth. Okay, so this is really amazing work. We'll get back to carbon cycle because that's what we are trying to do. We just want to this is carbon cycle. Of course we are looking at CO2 variations in the past. It just gives you a sense that sources and sinks of CO2 change in the natural world by large amounts, but now we are changing it by a huge amount at a very fast rate, and this is what we have to worry about. And we'll come back and look at some numbers again. If you're very young and you cannot understand the details, no need to worry, just ask your parents, ask your siblings and bug them to say what is happening, what are we doing, what can we do about it, and what you need to worry about and what you can do about it, and so on and so forth. We'll come back and meet in the next podcast and talk more about some numbers in the carbon cycle. Of course we have to come back and look at how much petrol, coal, oil and gas we are burning and how much CO2 we are releasing and where all that is going and so on and so forth. Okay, see you in the next podcast.